So, hi there. We've got another head scratcher here, another geometric reasoning problem, which is popped up on Facebook. Probably, I don't know how many I'm down now, but in they keep coming. It kind of sort of shouldn't click on them really, but curiosity really. This one is a quadrilateral problem with a quadrilateral with 4 right angles. So it could be a square, could be a rectangle, and inside we have a series of other checkered rectangles, different colours. It looks just a little bit like Mondrian art. That guy, I can't remember where he was from, probably Dutch, who basically made sort of modern art type pictures of rectangles looking like that. Not my thing. Anyway, sorry, I digress. So what we have is a bottom left unknown rectangle in dark blue. I'm just going to label that capital A, as I have a want to label unknown areas. And we've got a series of other areas we do know, 20, 40, 15, 30 and 70. And the kind of key to this is the fact that they share, or some of them share common widths, okay, and the fact that they're scaled up areas. So by way of example, the red is obviously been scaled up by a factor of 2 to make the purple, and the dark sort of yellow has been scaled up to make the light yellow 40, and they share a common width. So what I'm going to do initially is I'm going to label the smallest side length x, which is the height of the 15 centimeter red rectangle. I'll try that and label that again. Okay, now by argument that it's doubled for the purple and it shares the common width, we know therefore that's 2x. Okay, and we also know therefore that this is 2x, and by the same argument it's doubled in area, so same width, that's obviously going to be 4x. So immediately I can kind of put in, I'm going to just throw in a arrow here, so I know that that length there is actually 6x units, 6x centimeters. Okay, now down here I'm going to label this one A, this width. Okay, I don't know what that is. Okay, maybe I should use Y, but I'm going to use A, because what I now want to do is work out the distance between so the length of the purple rectangle, and I know therefore because it's 3 over 2 times bigger, this actually is 3a upon 2. Okay, so once again I can sort of label something in terms of an unknown. I'm building this problem up step by step, and I'm going to see where I'm going with it. I'm hoping we're going to be successful. So I know that that's 3 over 2, and then plus the a, which is 2a over 2, so that length there is 5a upon 2. Okay, so the only thing we don't actually know is b here. Well, we don't know very much of it, but we're just going to label that b, and if we can work out what that is, and we know that the height of that rectangle, the blue one, is 3x also, then hopefully we'll be able to figure out what a is. So we need to put some relationships together. Okay, so let's look at the red rectangle. So I know, using the red rectangle, sounds like a tongue twister, using the red rectangle width, multiplying it by its height, so 3a over 2 times x, I know that that's equal to 15. So I'm just going to write 3ax is equal to 30. Okay, so there's a relationship between a and x. I'm not going to, okay, let's just go one step further. So I know ax is 10. Let's just leave it like that. Okay, so there's something that I can write down, a relationship between two variables. What else do I know? Okay, so that's sort of used this rectangle. I could also use the dark yellow one here. Is this going to help? 2ax equals 20, so we end up with ax is 10, exactly the same thing, so that's not very useful. Okay, let me think about, okay, let's go for the entire rectangle area, shall we? So I'm just sort of fishing around for ideas here. So if I multiply 6x, which is the height of the rectangle, the whole thing, by its width, which is 5a over 2 plus b, that's going to be equal to all my areas added up, so let's just circle them. So 70 plus 30 is 100, 140, 160, 175. Okay, so that's 175. Okay, I'm not going to put any units in. Expand this out, so that's going to be 30ax over 2, so that's going to be 15ax plus 6 xb, or bx, we'll do it that way around to be consistent, equals 175. Okay, oh, I haven't actually added the all-important thing we're trying to find, plus a. Okay, so we've got sort of some relationship here. What can we do now? Okay, so we know what ax is. Okay, we've just actually worked that out. So let's see what happens with this. So 15ax is going to be 15 times 10. So that's going to be 150. Okay, plus 6bx equals 175 plus a. Okay, so we'll simplify that a little bit more. A is going to be equal to 6bx, and I'm going to subtract 175 minus 25. Okay, so if we can find out what 6bx is, now what do we know about b? Okay, we do have some other information here actually. So let's just bench that for a minute. And I know the width, so the height of this rectangle, which we haven't yet used, is 3x, and I know the width of it is b plus 3a over 2. Okay, so that could actually come in handy. So let's use that particular bit of information. So let's go 3x multiplied by b plus 3a over 2. And I know that that's equal to 70. Okay, so multiplying this out, end up with 3bx, sort of being consistent with the way in which we write things, plus, and we've got 3, so we've got 9ax over 2 equals 70. This is looking promising. Okay, so 9ax we know is going to be equal to, we can use this relationship here. So we know that 9ax is going to be equal to 9 lots of this. My 9s and 8s are starting to look similar. So that's equal to 90. So 9ax over 2 is equal to 45. Okay, so we now know that 3bx plus 45 equals 70. And we've actually established that the area that we're actually looking for is going to be equal to 3bx, conveniently. Okay, so that's that area that we're looking for, and we already have that now, so I can replace that with a. A is equal to 70 minus 45, and we just somehow squeezed that in. Last bit of the hurdle, a is equal to 25. I'll put units in now. Centimeters. Wow, that was close. Centimeters squared. Okay, so that was a little bit of an ad lib problem solved there. Just forming equations and seeing what I can do with them. So I hope that didn't get too confusing. Anyway, I'm sure we'll do some more soon. Thanks for watching.